Okay, so we are gonna now do video number 2 in our hydrologic modeling example for Chapter 3 of the Advanced GIS textbook. In this step 2, we are going to be calculating the flow direction across the Spanish Fork digital elevation model as we're stepping towards calculating the watershed area and the channels in the Spanish Fork River. Okay, so we are in the hydrology toolbox of spatial analyst tools within ArcGIS. And so the next step after filling the DM is what we're on now, which is called flow direction. Again, remember these are not ordered in the order that you do them, they're alphabetical. So flow direction is step 2 after filling. And it says for the inputs here, input surface raster, and that's going to be the one we just filled. Okay. And what it's going to output is a flow direction raster. And so the default naming is flow direct underscore fill one. I'm going to say flow direction Spanish Fork watershed or Spanish Fork D watershed. Okay. Apologize for the dogs barking. And so it says there's a few options here. Force all edge cells to flow outward. I'm not going to do that. It's not necessary. The edges are outside of our watershed, not worried about them anyways. Output a drop raster. I don't need to do that either. And the flow direction type is D8. There's some others that we could use, but yeah, we're using D8. Which is what's described in the chapter. And that's pretty much it. So you just enter the filled DEM, you give it an output name, it's saving to my geodatabase, so I haven't had to add like another file format distinguisher at the end of there, like .geotiff or something. So it's just a geodatabase or raster grid. So we'll run that. This will be taking us a minute because it's a pretty big area. It shouldn't be too bad because we're using a 30-meter DEM. I will caution you at this point, when you're doing watershed analyses, you may see that it happens pretty quickly in this 30-meter case, but if you use LiDAR, you're talking about orders of magnitude of longer processing time. It's usually not an issue for this step, which is flow direction, but it does very much become an issue when we do the third step, which is flow accumulation in the next video. That can take a really long time for a big watershed that, like what we're calculating here. You might wait 30, 40 minutes for that to complete, depending on the processing power of your computer. Okay, so here's our flow direction watershed. Well, it's not flow direction, but it's in this, it's not a watershed, but it is flow direction where the Spanish Fork watershed is. And so what it's done is basically for each pixel in the original DEM, so if we zoom way in, so we're starting to see pixels. So maybe you can see those pixels under there. Let's change this a little bit. So you can see these different pixel colors. That's not super helpful. Okay, so let's so now you can see the pixels. Okay, so there's my DEM pixels. Now I'm going to turn on this flow direction raster that we've just produced here in a second. But hopefully you can see that in this area, you kind of lower elevation is over here, higher is here and here, based upon the color, right? And so you would expect water to flow from the reds, the high, down to over here. And so what's going to happen here is this flow direction raster, these values actually just tell us kind of what neighboring pixel flows to. Okay. So if I look at, all these blue ones here is number 16. So what does that mean? So um, 16 means that it flows to the pixel to the left of it. So if we go back here, that means that generally all the flow is from right to left over here. The purple is 64. That means it flows up. So if I turn that back off, so in here, there's a little area, it flows this way off of this high here, that way. So on and so forth. Each of these, so 1 is to the right, 2 is to the lower left, 4 is down, 8 is to the lower left, 16 is to the left, upper left is 32, up is 64, and upper right is 128. And so, so there's some upper right, so this pixel flows to that pixel and stuff in this area. So yeah, that's a flow direction raster. It might look similar to you as something like what's called a aspect map. Aspect map is the direction that slopes face. And a lot of times aspect maps are classified like north, east, west, but not just that, but north, northeast, etc. And so it looks kind of similar. It's like these slopes are to the northeast, and it kind of looks one color, something like that. So there is some similarities to an aspect map with this flow direction in terms of how it appears, but it's definitely differently coded. An aspect map is in units of degrees, 0 to 360, and then it can be classified. Okay, so there's our flow direction raster. It's in those 8-bit integers. What else to say about that? I think that's pretty much it. So the next step will, in the next video will be flow accumulation, and that will build upon this flow direction raster. Okay, so let's end this video and we'll go on to the next one.